Okay, welcome to video number 3. I'm going to make some notes here so I know where all these start. This is going to be a lot of pages. So this is where video 3 starts. 13. The graph of the polar function r equals f of theta is given in the polar coordinate system, which the following defines the graph from 0 to 2 pi. So this is a polar rose. Since it is a rose, it must be of the form a sine in theta. We have 3 petals, or sine or cosine. Sine or cosine. One of these two. And so that means we can automatically rule out these that have a vertical shift. So now we need to figure out the only difference between these two is sine and cosine. So if you remember, how do we tell the difference? Cosine starts at a max, while sine starts at a middle. Looking at this, 0, the polar axis right here, we are starting at a max. We are starting at a max. Therefore, this should be cosine, because we are starting at a max. Okay. 14. The polar function r equals f of theta, where f is 2 over theta, interesting, is defined from less than or equal to, or greater than, theta is greater than or equal to 1. Which of the following describes the graph in the polar coordinate system? So this should be, there is no trig function, so this should be a spiral. Let's see here. Is a line along the polar axis? Nope, we have both an r and a theta, so it's not a line. It should be a spiral. The graph is a line along the polar axis, for which the increasing angle correspond to the increasing radii. Is a line along the polar axis, the x-axis, for which increasing angle measures corresponding to a decreasing radii? No, line, those shouldn't work. Oh, good, it says spiral down here. Okay, so it's a spiral, and the graph is a spiral which increasing angle measures correspond to decreasing radii. So is the radii negative or is it positive? So if it's increasing angle measures correspond to an increasing radii. The radii should be getting bigger, I think, but let's just check a few values here. So if I wanted to check a few values, so let's do 0. It has to be bigger than 1. So let's just plug in some 1. So let's do, if I plug in 1, that's the lowest number it can be, I would get 2. If I plug in 2, I would get 1. If I plug in 3, I would get 2/3. Oh, so the radii is getting smaller. 4, I would get 1/2. So it is getting smaller and smaller. So it looks like what this graph would do is it would start at 2, and then it would slowly get smaller and smaller and spiral into 0. So it should have a decreasing radii, because all of these have a decreasing rate of change, which makes sense because that is the variable is in the denominator. Cool. 15. Let f of theta be a polar function where f of theta equals 5. Just plain old boring 5. So this is going to be a circle. And if that is 5, it should just be a circle with a radius of 5 on the center. There is no trig function. There is no moving that around. From 0 to pi. Oh, so we don't even need this whole thing. We just have to go from 0 all the way over to pi. So we only need this chunk right there. And appears as a semicircle. Great, that's what I got. The graph in which the following polar function in the polar system is the same semicircle. So we want the same semicircle, so this should have a radius of 5. So where g is -5, so if I graphed g, so this would a, so -5 for 0 to pi. So if I did that, this would have values like 0, -5. So 0, -5 starts there. Great. And then all of this would be, so this would be like pi over 2. So going all the way to pi, it would be down here. This would still be the same quadrant, but the semicircle does not appear to be the same. Where h of theta is 1/5, well, that's just going to be a really small one, so that one's definitely not right. And here it is for -5 from pi over to 2 pi. So -5 causes it to flip across, and since I'm measuring the other half of it, it causes it to flip up, so it should be C. And then that's just a small circle, so it should be C. This graphs the bottom half. These two are too small. This graphs the pi to 2 pi, but because it's negative, it would flip it up across the pole. Okay. The graph of the polar function r equals g of theta. So g of theta is, it's a circle. There's no multiplier here. It's a circle that has a phase shift. So we did not talk about phase shift in class, but phase shift moves things sideways. Sideways in a polar graph is in a circle. So this has taken 4 cosine. So usually the point would be right here. So usually for cosine, the starting point would be right here. That should have been our starting point, but this phase shift of plus pi over 3 has moved it down to here. So this is the phase shift of plus pi over 3. Which of the following descriptions is true? So for the values from values of theta from pi over 2 to pi correspond to the portion of the graph of quadrant 1. So if I go from pi, so my first value should have been here. Okay, my first value is right there. My second value, so 4 cosine plus pi over 3 gives a phase shift backwards. Yeah, phase shift works backwards. So this is 0, and it would go up to, no, it should not be quadrant 1. These are all pi over 2. So let's start at pi over 2. If I plug pi over 2 into here, we get 4 cosine of pi over 2 plus pi over 3. I get these to common denominators. This should be 3 pi over 6 plus 2 pi over 6. So this should be 5 pi over 6. So cosine of 5 pi over 6 is root 3 over 2. So this should be 4 square roots of 3 over 2. So 2 square roots of 3, which is about 1.7. So pi over 2 should be 1.7 up here. What have I done wrong? Cosine of pi over 3. Oh, no, sorry. Hang on. Pi over 2 should output, so this right here should output 1.7. Oh, cosine of 5 pi over 6 is negative. This should be a negative. I messed up there. Cosine of 5 pi over 6 should be a negative, so this should be a negative 1.7. So should be pi over 2 negative 1.7. That is way bigger than 1.7. Pi over 2, 1.7. Is there something I missed here? Just to make sure I did my math right, if for cosine of theta plus second pi over 3. And then I should be able to take, we should do vars, y vars function, y function, and I'm going to plug in pi over 2. Negative 3.4. What did I do wrong here? Pi over 6. So negative 3.4 would be this point right here. Great. But what did I do wrong there? That's weird. Cosine of, this would be cosine of 3 pi over 6 plus 2 pi over 6, which is 5 pi over 6. Cosine of 5 pi over 6 should be negative root 3 over 2, negative root 3 over 2 times 4. Is that where I made a mistake? What is negative? Sorry, I'm getting sidetracked here. I need to figure out where I made a mistake so I can not make it in the future. Oh, I guess so. I did some mental math here that was wrong. Negative 2 square roots of 3 is not 1.7. Square root of 3. Oh, I know what I did wrong. I halved it twice. I halved it twice. Bad mental math. Bad mental math. Okay. So we're going to use this from now on for this one. So that goes right there. And then let's plug in pi over 6. So if we have, so pi over 2 came out with a negative 3.4. A pi over, what's after pi over, so let's go with 2 pi over 3 would be the next section here. So if I plugged in 2 pi divided by 3, I get a negative 4 exactly. So that would put me right here. So it should be this spot right here. And then I go back in and change it. And now I'm going to do the next one, which is going to be 3 pi over 4 is the next fancy line. And I get negative 3.8. So this one should be negative 3.8. That tracks. It is really close. So we're on that section right there. I go again. And we will type in 5 pi over 6. And so that is another 3 point something. So right here. And it looks like it's just going to complete this whole section here in quadrant 4. So it should correspond with quadrant 4. And that is just as I keep typing these in, I fill out this domain. So it should end up all of quadrant 4 because I'm all in quadrant 4 here. This is quadrant 4. Okay. Where are we at? We're at 14 minutes. See what the next page looks like. Ah, it's just one page. Let's go. One question. The graph of the function y equals f of x is shown in the xy plane, which the following is the graph of the polar function in the polar coordinate system. So we want to convert this to, wait a minute, which of the following is the graph? Oh, just what's this graph look like in the polar section? So this is a cosine graph, right? We're starting at a max, so we know it has to be cosine. Also, we know this is because there is a vertical shift, so we should be doing a 1 plus, which tells us this is a limacon with a loop. That little bit, that's our inner loop. This is our inner loop, so we should have a limacon with an inner loop. Should be cosine, and we should have a vertical shift of 1 and an amplitude of 2, so we should have 2 cosine. Theta should be our equation. But let's see, we're looking for a limacon with an inner loop. Oh, these are all limacons with an inner loop. We are looking to start at a max, so 0 should be a max, so that rules out A. This one's a max, 0 is a max right here, so it could be this one. 0 is not a max, so it can't be C. And D, 0 would be, so if this was 0, it could be this point over here if this was a negative output. If 0 had a negative output, this would be the extreme. This is an extrema. But if we look at our graph, 0 has a positive output, so it can't be this one. So it must be B. It must be B. 18 is just, we'll knock out 2 more pages real quick, and then we'll cut this video off. 18 starts at the bottom of this page. Which of the following graphs of the polar function, yada, 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 2 cosine 2 theta, so this is going to have 2 petals. This is a rose with 2 petals. But I'm not graphing the entire rose. I'm only graphing from negative pi over 2 to pi over 2. So we're looking for, not 2 petals, we rose with 4 petals. So since we only want from negative pi over 2 to pi over 2, that's the limited range. So we're not going to have A. A, this is this distance, this is a distance of pi. Not 2 pi. It would take 2 pi, sorry, this is a distance of pi. It would take 2 pi to make all the petals, so we're looking for a half 1. And this is going to be quadrants -1 and quadrants +1. So here on these, cosine is always positive. Cosine is positive in these 2 intervals. So, and since it's normal cosine, right, there's no negative in front, no negative, so that means we need to start at a max. So this one starts at a max, and would go, that is your positive values right there. And then this one starts at a minimum. This one is definitely doesn't have, oh, it has this one, right? So not start at max, but it has to cross this point. This point is, and, sorry, let me restart. 0 is in the middle of these 2, right? 0 is in the middle of these 2, which means from the starting point, from here, I should have lines going away in both directions. Here, it doesn't even cross it, so it can't be C. Here has that point of 0, but I only have lines going in one direction away, not from the other direction. So it can't be D either, so it has to be B. So So knowing how all these graphs work and what they look like, the reasoning behind it, makes a lot of these questions easy. But again, you have to understand what's happening, and that's the tough part. Okay, I will see you guys in, I guess that would be video 4. Okay.